Hi everyone, I am Jay and today I am presenting one of my most advanced engineering projects, an autonomous drone based pipeline inspection and leak detection system. This drone is designed to autonomously follow pipelines, detect gas leaks, map leak intensity, and transmit live data for remote monitoring. Let's start with the purpose of the system. In industrial environments like oil, pipeline, chemical transport lines, sewer pipes, and underground conduits, physical inspection is risky, slow, and often impossible for humans. Leaks can go undetectable for months, causing financial loss and huge safety problems. So instead of sending people inside dangerous environments, we can send drones. This drone carries a complete sensing payload. It includes 6 different MQ series sensors that detects LPG, methane, alcohol vapors, carbon monoxide, hydrogen, and ammonia based compounds. I also use a PM2.5 sharp dust sensor for particulate measurements, a DHT 111 for temperature and humidity, a BMP 280 for air pressure and altitude, and an MPU 6050 for inertial measurements unit for orientation and motion tracking. All these sensors are connected to an ESP32 microcontroller, which continuously reads the raw sensor values. The ESP32 then packages this into a structured data packet that includes every measurement along with IMU and altitude data. This data is continuously streamed to Raspberry Pi over UART serial link. The Raspberry Pi acts as the main processing and visualizing brain. It uses a webcam that is mounted downward facing, giving the drone a real time visual feed of the pipe. The system performs basic pipe detection using edge detection and line transforms, allowing the drone to visually track and follow the pipe. Along with this, we have also trained a custom YOLO V5 model that is trained to detect only pipes. Now let me explain the visualization and analytics. On the interface, we see several real-time time views simultaneously. First, we have the live camera feed, where the detected pipe boundaries are highlighted on the screen. This gives visual confirmation that the drone is aligned correctly. Next, we have a full 3D leak map. This is not just a graph, it is a spatial representation. The x axis represents the distance traveled along the pipe, y axis represents altitude, and z axis represents gas leak intensity. So we can literally see where along the pipe leak get worse or better in 3D space. We also have a time series 2D plot that shows leak intensity versus distance. This gives a very intuitive view of where the leak spike occurs. If methane suddenly jumps or CO rises, it immediately appears here. On the bottom, there's a live numeric dashboard showing LPG, CH4, CO, H2, ammonia, particulate matter, temperature, humidity, altitude, and all accelerometer and gyroscope values from here. Operators get exact real time numerical data, not just graphs. A unique feature of the UI is the drone over pipe simulation. This shows a simplified graphical model of drone hovering over the pipe. The drone position dynamically responds based on accelerometer data. If the drone tilts or moves sideways, the simulation reflects that. If leak intensity rises below the drone, a warming circle grows under it. Another UI component is the mini map. This shows the drone traveled path along the pipeline from top down view. Areas with high leak concentration are colored coded and giving a heat map like representation of where leak occurs. We also implement leak trend forecasting. The system calculates a derivative of leak intensity with respect to distance, basically how fast the leak level is growing or falling. This predicts the leak intensity about 1 meter ahead of the drone. This provides early warning capability even before the drone reaches the leak zone. A very important aspect of the system is remote accessibility. All the data, including live camera, stream, and sensor output, can be served over a local web server. That means any supervisor on the network or even remotely over the internet can monitor the drone in real time using a web browser. Let's talk about the application. This technology can be deployed in all oil pipelines, water treatment uh, pipelines, underground sewage lines, chemical factories, mining tunnels, and even nuclear waste facilities. Basically, anywhere that human inspection is difficult, dangerous, or inefficient. Looking ahead, future upgrades includes machine learning based crack detection system, integrating real-time SLAM based navigation for indoor localization without GPS, and adding long-range communication like LoRa or GSM for remote deployments. We can also upgrade the drone to operate autonomously, following pipelines using computer vision and sensor fusion. To summarize this project, it's not just a drone, it is a complete intelligent mobile inspection platform. It senses, analyzes, maps, visualizes, and broadcasts environmental data. It improves safety, reduces maintenance cost, and provides a real time actionable insight. Thank you for watching, and I hope you enjoyed the presentation.